Hello guys, how you doing today? It is Mr. Epalanga again, aka your chemistry teacher, Mr. Julino. Okay guys, so today we will continue with our lesson in alkanes. I hope you guys have done the homework. And again, if you still have questions, do not hesitate to contact me either via email or through WhatsApp. Right, so let's continue. And today we will start with isomerism. So we will talk about isomers. Okay? So isomers are different compounds that have the same molecular formula. So the atoms are arranged in a different order. Okay? So it means isomers. Okay? Isomers. In isomers we have, okay, the same, let me change the color here. So we have the same molecular formula, the same molecular formula, and we have different structural formula. Okay, so the number of atoms are the same, but the structure is different. Okay, example, let's say we have N-butyl and N-butane and isobutane. So butane we know we have 1, 2, 3, 1, 2, 3, 4. Okay, and then isobutyl will have 1, 2, 3, and then 4. 1, 2, 3, 4. Okay, writing in a different order. So this will be CH3, then CH2, CH2, CH3. Okay, but for this one will be CH3, CH, CH3, and then CH3. Now we have in both cases the same molecular structure or molecular formula, sorry, which is C4H10. Okay, remember the general rule is CnH2n plus 2. So if n is equal to 4, will be C4H will be 2 times 4, 8 plus 2, 10. Okay, and this formula is the same for butane or N-butane, which means normal butane. Okay, it's the same, exactly the same formula. And here is isobutane. Okay, or methyl, 2-methyl in this case, 2-methyl butane, 2-methyl propane. Okay, now it's just different way, it's the same structure, two different names. Okay, now they have the same number of atoms but different structure. So this is what isomers are. Okay, so let's move on. So the first three members of alkanes, methane, ethane, and propane, don't have isomers. Why? Because we only have 3 carbons and they can be ordered in any fashion. Okay, so butane, however, does have isomers, and these are shown below. Now, the first compound, one has the longest chain. Okay, N-butane has the longest chain. Okay, with 4 carbons, and it is called N-butane. And the second has the longest chain of 3 carbons. Okay, but both compounds have the same molecular formula. Like this is just what I've just said. Okay, the first isomers, N has an unbranched, or he does not have a branch. Okay, or carbon chain. Okay, but the second isomers is isobutane. Okay, which means it has a methyl group attached to the second carbon. So this is more or less the molecular module, how they look like. Okay, in this case there are 2 different possible structures for C4H10. So like we said, if you remember guys, when in the last chapter when we talk about introduction to organic compounds, I've explained to you that the same molecular formula in organic chemistry could present different structures. That's why we need to use the structural formula. So structural isomers have the same molecular formula and different structures. And another important thing to remember is that the first three compounds of alkane group do not have isomers. So, for example, methane, ethane, propane do not have isomers. But butane, however, has, because we have N-butane and we have cycle or isobutane. Okay, they are isomers. And we can see that these isomers, these structural isomers, will have different physical properties, okay? Even different chemical properties as well. So we can see here, pentane has a melting point of minus 130. 2-methylbutane has minus 160 degrees Celsius. And when we come to neopentane or 2,2-dimethylpropane, will be minus 17. So we can see that these isomers are different compounds with different properties. Even density is quite close, but we can see the boiling point is different as well. Now, the boiling point will decrease. If you remember, we said in the video we talked about the properties of alkenes. We say that the boiling point will decrease with branching. Okay, branching will decrease the boiling point of the compound, of organic compounds in general. So the more branch we have, the lower the boiling point. Okay, so now before we go to the properties, let's practice a bit more on this topic of isomers. Okay, now can you give me 3 isomers of this compound C6H14. Give me 3 isomers. I want you to stop the video and try to solve it by yourself. Right, so hopefully guys you've done correctly. Now let's try to do together. So we need 3 isomers. So the first one always will be the straight chain. So it'll be 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Okay, this is N-hexane. Okay, it could be done this way as well. 3 S 2 CH 2 CH 2 1 2 3 4 5 and 6 carbon. Okay. Okay. Now we could also, this is the first isomer. Now let's do the next one. The next one will have one branch. So it is still C6H14. But this time we will have 1, 2, 3, 4, 5, 6. Okay, this is 2-methylpentane or isohexane. So it could be written in this way as well: CH3, CH, CH3, then CH2, CH2, CH3. 1, 2, 3, 4, 5, 6. Okay, so this is the second isomer. The third one could be still CHX14, could be this isomer. Okay, this is neobutane. Okay, this is, let me just write the name of this. This is 2-methyl dimethylpentane, or the name could be isohexane. Okay, because we have this material here, but here we have CH3 here, CH3 here, because we have two methyl groups. Then we have CH2, CH2, so we 1, 2, 3, 4, 5, 6, 7. Oh, actually, this structure is wrong, so let me, yes, now it is correct. Okay, so you see H3 here, so it's 1, 2, 3, 4, 5, 6. So this is 2, 2 dimethyl butane or neohexane. Okay, this is another isomer of C6H14. Okay, now we can still write one more isomer for this compound. Okay, with the same molecular formula, C6H14. Okay, but here now we will have something like this. Okay, so the 1, 2, 3, 4, 5, 6. Okay, of CH3, CH3, and then CH3, CH3. Okay, now the name here would be 2, 3 dimethyl or dimethyl if you prefer butane. So as we can see, here, so we have three different, okay, we have 1, 2, 3, 4 different isomers. Okay, I know I've asked for 3, but I've written here, okay, 4. So if you write any of these 4, you are correct. Okay, but if I ask for 3, you could write any combination of 3 here. Okay, now the more, the longest the chain, the more isomers we have. Okay, for example, for butane we have 2 isomers. For pentane, we have 3 isomers. For hexane, we have 4 isomers. For heptane, we have 5, and so on and so forth. So the longest the chain, the more isomers we could have, because it would mean different orientation. Okay, now let's try a different compound. This time let's try no name. Okay, so give me, for example, if I ask for 5, give me 5 isomers of no name. Okay, so firstly we have to remind ourselves that no name we have 9 carbon, so we C9. So H will be 9 times 2, 18 plus 2, 20. So we H20. So the first one is the straight chain. The 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have this one, and we could have isononane. So the 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3. So isononane. So we could have, so this is nonane or any nonane. We have isononane, also 2-methyl octane. Okay, and then we could have neononane. So it would be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oops. Let me clean this. Let me just clean this stuff. will be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have one more. Oops. Let me close. Okay. Okay, 7, 8, 9. Okay. This is neo, no name of 2, 2 dimethyl. Okay, ethane. Oops. Ethane. Alright, so we could have other structures as well. Just so we will save some space. We could have some other structure as well. We could have 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, for example. Okay, this would be, if we count from here, will be 1, 2, 3, 4, 5, could be 2, 2, 3, 4. Then we have tetra, because it's 4, tetra methyl. Okay, and then 1, 2, 3, 4, 5, pentane. So as you can see, we can have many different isomers. Okay, we could have 1, 2, 3, 4, and then here we have 1, 2, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Let's say 8. Okay, 9, for example. So this is also an isomer of the name because we have 9 carbon here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the name would be, okay, would be 2. Okay, let's start with D, would be dimethyl, so the 2, comma, okay, 1, 2, 3, 4, 2, 4, dimethyl, okay, 2, 4, dimethyl, and then we will have 1, 2, 3, ethyl, because the number is 1, 2, 3, 4, 5. So it'll be 3 ethyl and then pentane. So how many isomers we have now? I have 5, 1, 2, 3, 4, 5. But we still could have more. We could have this 1, 2, 3, and then 4, 5, 6, 7, 8. Okay, let's say 9 here. So we could have any combination, okay, any structure, as long as it has 9 carbon, would be an isomer of no name. So the more carbon you have, the more possible combinations we also have. Okay. So let me give you another example, but before that, let's just make sure we've covered everything we have. So in general, so this is important. In general, the number of C increases the number of isomers, okay? Or the number of isomers increases the number of carbon atoms. So the more carbon we have, the more isomers we have. So we have here, okay, look here in this table. The number of possible isomers increases, but increases like, oh, rapidly. So C4 can have 2 isomers, C5, 3 isomers, C6, 5 isomers, C7, 9 isomers, C8, 18 isomers. You see, C15, okay, could have like 4,347 possible isomers. Now look at C20 and C30 and C40. It's like infinite numbers of isomers. So the more carbons we have, okay, the more possible isomer there is. Okay, I think that's it for isomers, and I hope you guys have got the general idea. So isomers are organic compounds with the same molecular formula and different structural formula. Okay, the difference is in the structure, but they have this exactly the same amount of atoms. All right, guys, that's it for today. So I hope to see you in our next video. Please, guys, stay blessed and stay safe. Bye.